So we have telescope. As I told you, we have two classification, right? We are speaking about the telescope now. So there are two lenses here. That is refracting telescope. We are speaking about refracting telescope. Okay, so here what happens here? This is the first lens, and this is the second lens. Okay. Now O is the objective, and E is the eye lens. So we have two rays. A ray which passes through optic center goes undeviated. Second ray, which is like these are the rays. Why two parallel rays? Because see, whenever suppose we are keeping the telescope like this, and like rays are coming from a far distance, rays are coming from a far point, means they will be parallel to each other. All these rays will be parallel to each other. Okay. Now what happens here? So here this is the second one. These are the two rays. So what will happen? This is A dash. This is what? A dash and B dash. And this is H. So here what happens? There are two rays. There are two rays here. This and this one. This and this one. So here there are two rays. So what will happen now? This one and this one. These are the emergent rays. So take it backward. This also take it backward. Okay. Now here beta is the angle. H is the height of the image, and FO is the side. FO is the focal length of the objective. FE is the focal length of the eye lens. Is that clear? Once again, we have two lenses. We have objective lens. This is objective, and this one is eye lens. Objective and eye lens, or eyepiece. Now, objective and eye lens, two rays. These are the parallel rays. After refraction, the image is formed here, which is what? H height. That is, this is the image. So the image of objective is acting like a object for the eye lens. Once again, the image of objective is acting like a object for the eye lens. Okay. So FO is the focal length of the object. F is the focal length of the eye lens. Clear? And beta is the angle. So we have magnification formula, and the image. If when you extend these rays backward, the image is formed somewhere at infinity. So is it a real image or virtual image?
Virtual.
It's a virtual image. Very good.
It's a virtual image.
Virtual image. So now we have magnification formula again. What is the magnification formula? Again, we have beta here, and again here, what is that? Here it is alpha. This is alpha, and this is also alpha. So we are saying angle subtended by image and angle subtended by object. So here we have beta is equal to magnification. Magnification formula is equal to what? Tan beta by tan alpha. What is alpha? Alpha is angle subtended by object. Angle subtended by object. Okay. And beta is what? Angle subtended by image. Angle subtended by image. So beta is equal to, that is m is equal to what? M is equal to beta by alpha. So what is that? Tan beta by tan alpha. So here we have tan beta is equal to, we have tan beta, tan alpha and tan beta. Tan alpha is equal to, what is the formula here? Tan alpha and tan beta, which is equal to, yeah, what is it? Will directly write that? Yeah. Okay. So I'm not going to write all these things. Okay, tan beta directly. So instead of wasting the steps, beta by alpha, which is equal to what? H by Fe and Fo by H. H by M is equal to H by Fe into Fo by H into Fo by H. This and this will go away. Answer is what? Fo by Fe. Answer is Fo by Fe. And what is the length of the telescope? L is equal to what? L is equal to Fo plus Fe. Is that clear? This is the length of the telescope. Is it clear? Once again, tan beta by tan alpha, beta by alpha. This is H by Fe and Fo by H. Cancel out. We'll get Fo by Fe. And L is what? Length of the barrel in which these two lenses are mounted. And these two lenses are mounted in such a way that the principal axis of, we say coaxially mounted, means principal axis of both the lenses should match each other. And mostly we have to take one more thing. The object is every time bigger. Why? The reason is to capture more light. Okay, to capture more light. The reason behind using a big convex lens or objective convex lens is to capture more light. Understood now? Is that clear? So terrestrial telescopes have a pair of inverted lenses. Okay, so this is mostly a terrestrial telescope, as I told you, refracting telescope. Okay, is it clear, all of you? So
yes, sir.
yeah, we will do quickly a numerical on both of them, the convex lens and concave lens. Okay, sorry, I mean the refracting telescope and the microscope in the problem. In compound microscope, here Fe is 1 centimeter, Fo is 2 centimeter. Okay, 1 and 2, Fo is 2, Fo is 1, Fo is 1, Fe is 2, and L is equal to 20 centimeter. L equal to 20 centimeter. So what is the magnification? A magnification is equal to what? L by Fo d by Fe. L by Fo into d by Fe. So magnification is equal to what? 20 by 1 and 25 by 2. 20 by 1, 25 by 2. So because d is 25 centimeters. Answer is what? 250. Answer is 250 times. Clear? Is that clear?
Yes, sir.
Yeah. Please copy this. And we'll do one formula for this also, for the power of telescope. So if Fo is equal to, for this particular numerical, if Fo is equal to 100 centimeter and Fe is equal to 1 centimeter, the formula is M is equal to what? 100 by 1 will become 100. Magnification is 100. Clear? Is that clear?
So for which the same compound microscope one?
Yeah. Fo is equal
Okay,
to 100 and Fe is equal to 1 centimeter for this refracting telescope. This is for refracting telescope. Only directly, no? Fo by Fe. Just substitute, we'll get the answer. Okay?
Yes, sir.
Done, all of you?
yes, sir.
Okay.
Yes, sir.
Okay. Now, are you understanding, all of you? Ismail and all.
Yes, sir.
Yes, sir.
Learn this now very well. Last one is what? Reflecting telescope or Cassegrain telescope. Reflecting telescope. Reflecting telescope. We have name as Cassegrain. Reflecting telescope or Cassegrain telescope. So what will happen now? See here, we have now here. So now here we have, this is, this is a concave lens, concave mirror, sorry. This is a concave mirror. And here there is a this is eyepiece. We have this one is a convex lens. This is a convex lens. Convex mirror. Okay, this is said to be secondary mirror. Secondary mirror, which is a convex mirror. Now, so what happens here? A ray which incidents on the mirror. Okay, these are it's a very huge one. It's not a small one, very huge one. Very big concave mirror. So when the light incidents on this, it converges here. Okay, here also it converges. Okay, it converges. Then what happens? It will reflect here. Okay. After that it comes to this point. It comes to this point. Understood now? So image is formed here. Image is formed in this way. This is the secondary mirror, and this is the objective mirror, which is primary. This is objective mirror, also known as objective mirror, or concave mirror, or primary mirror. Okay, primary. There are three names for this: objective mirror, or concave, or primary mirror. And this is a secondary mirror or convex mirror. Convex mirror. So what happens here? Here once again from the beginning, light rays incident on this concave mirror from a far object, like from the space, you're looking into the space. Now, what happens here? It will 1 second. So now, so rays will incident here. It will reflect back to this mirror again. After that, it will again reflect back into the eye lens or eyepiece. Here, so this is the thing happens in the Cassegrain telescope. So see one more thing. We are using only the mirrors. What are the advantages of mirrors, reflecting telescope over refracting telescope? This question was asked in the boards. What are the advantages of reflecting telescope over refracting telescope? In reflecting telescope, we use mirrors. In refracting telescope, we use lenses. So in mirrors, there is no aberration. What is aberration again? There is a term called aberration. Okay, aberration. What is aberration? Aberration means defect in the quality of the image. Defect in the quality of the image. Quality of the image is known as aberration. We have two types of aberration. One is
monochromatic,
spherical aberration, spherical and chromatic. So two types of aberration. So with the lenses, we get this type of problem: spherical aberration and chromatic aberration. But with mirrors, we don't have this problem. This problem is rectified using the mirrors. But the question is, will this concave, because this concave mirror is is a hurdle actually for the incident rays, right? When the rays are coming, this is a hurdle in between, or like it is preventing some rays to reach the mirror. So does it affect? No, it doesn't affect. Maybe very, very less, because this is a very huge mirror. So it captures most of the rays. Okay, it captures most of the rays. So what happens? So this doesn't affect that much. Maybe 1%, maybe that, not more than that. So images from somewhere here. So if you speak about the mirrors, we have, the telescopes. This is in India we have, and we have in Mexico. In Mexico, on the top of the mountain, they fix very big telescope. Okay. And also one is in China. Recently, when there was Expo 2020, they showed this in the Expo. They showed the biggest telescope of the world, which is in China now. Okay. Not only that, we have in America also we have many telescopes which we are focusing on the in the space to explore the space, or to find out the heavenly objects or celestial bodies in the space, to study about these things. So there is a study called astronomy and astrophysics. Astronomy is study of heavenly bodies or celestial bodies, because the atheists told where is heaven. So then immediately they change the word to celestial bodies, heavenly bodies or celestial bodies. So that is for the space. Now, so astrophysics means study of motion of heavenly bodies. That is astrophysics. So for these people, then they definitely need telescopes to explore the space. So we have two telescopes in the space also. One is a Hubble telescope. It takes the pictures, captures the pictures from the space, and it will give it to the NASA in US. We have one more. India also has set up one telescope in space. I don't remember the name. They give the images to the ISRO, and we start studying the space. Okay, about explore the space. Is that clear, all of you? Is it clear?
Yes, sir.
Yeah. So I will explain you. Maybe little interested in the spherical and chromatic aberration. In spherical aberration, what will happen is, like, suppose this is the lens. So this is the focal. So what happens? These are the rays. The rays which after refraction they meet at the focal point. Okay. This is the focal point. Now what happens? Sometimes the rays which are very close to that is they form the image here. And here this is what? This is marginal rays, and this is the paraxial rays. So marginal rays meet before the paraxial rays. Means we got two focal points, FM and FP. FM is the focal point due to the marginal means away from the principal axis. Paraxial means very close to the principal axis. So they don't meet at the same point, and the image is blurred. So the quality of the image is not good. That is said to be spherical aberration. Chromatic aberration means, like, suppose this is the lens, and we divide the lens into so many parts like this. So what happens? This ray, when the white light forms here, what happens? They form here the image. Image is formed like this. So what happens? The violet.
There's a change in color.
And this is red color. So like the prism is divided into many parts. Each of them is acting like a lens. When the white light incidents on this one, so violet bends more than the red color light. So we get one focal point for violet, one for red, one for blue, like that. So again, all the colors are mixed up. So that will give again, it's not a clear image or a fine image. So it's a blur image. So this is known as chromatic aberration. Understood now? So these two situations are not there in mirror. Mirror is reflecting as it is. There is nothing to worry about the aberrations. But how big are the mirrors? If you really speak about these mirrors, these are equal to, right from 6 meters in radius to maybe 20 meters in the radius also. That much big mirrors we have. And these are mounted on the mountains. These are installed on the big mountains, huge mountains. So, clear? So, please copy.